Welcome back to Mr. Speller's Math Tutorials. It's me, AJ. Today we're going to use Desmos to create the Autobot insignia. And we're going to do that using a parabola function, two absolute value functions, and several linear functions. Please stay tuned. Alright, let's go ahead and get started. Before we look at the design elements and the formulas, let's take a look at what our logo or insignia is going to look like. Alright, so here is our insignia. Alright, notice that it's made up of, like I said, several lines. We have our absolute value functions here and here. We have our parabola up there at the top. And now let's go back and take a look at all the design elements. So again, like I said, the parabola as the top, like the crown of the head. We're going to have absolute values like around the what I'm calling like the helmet area, just below and just above the eyebrows. For the lines, we're going to use this point slope formula. With the point slope formula, we're going to be given 2 points. We're going to use those 2 points to calculate m, which is going to be the slope. And then we're going to use the slope in the point slope formula to create the line that we need. We also have the formula for parabola, where that's y equals a times x squared, where a is going to be a compression, which is just a value or a constant. In this case, we're going to make the parabolas wider. We have the absolute value function, y equals a times the absolute value of x. Again, a is going to be used as a compression to make the absolute value or the v-type shape wider. Also, remember that your domain values are the x values and that your range values are the y values. All right, let's take a look at what I've done here by hand, doing my hand analysis. What I've done here is actually graphed all the points on a piece of graph paper, and I've actually scanned it in. What we're going to do is I'm going to prep the next shot. I'm going to prep several of the dots to make it easier to follow this tutorial. So we're going to begin that in the next video. All right, so we're going to begin by making the parabola here at the top or crown of the head. All right, so this here is the parabola. And notice here this parabola has a vertex of 0, 5.5. And then we have the 2 points, -4, 5, and +4, 5. All right, so let's go ahead and go to Desmos here and begin the process. All right, so here I have those dots in place. Let's go ahead and turn them on so you can see the -4, 5. I'm sorry, the -4, 5, +4, 5, and then here the vertex at 0, 5, 5. So we're gonna start with y equals. We're gonna put place in here x to the second power, so that we have our parabola. We want the parabola to, and right now it's opening upward, we want it to open down, so we place the negative in front. And we also have to apply a vertical shift, and that vertical shift here is going to be a positive 5.5 because we want this moved up 5.5 units. So here we just add on 5.5, and then that there moves everything up. Let's go ahead and go to let's go ahead and do some analysis here so that we can figure out what we want the compression to be. As a matter of fact, let's be a little more explicit here. So I'm going to place this x squared value in parentheses, and I want to show the implied -1 here in front. We're going to change this -1 into another number so that we can make this parabola wider. So for example, let's say I made this let's say I made it 0.5. You see it's gotten wider. Let's make it 0.3 even wider, 0.2 even wider. So I want to figure out what exact compression or value I need to put here so that I'm actually going to intersect here at the -4, 5 and the +4, 5. So let's use the point here, -4, 5. All right, so let's go back here and let's go ahead and write in what we currently have. So we're saying here that we already have, let's change this to purple. Well, the equation that we already have is y equals, let's change the size here, that y equals, and I'm going to be explicit, -1 x to the second plus, and the shift that we placed here was 5.5. The point that I said we're going to use here, the point is going to be the -4, 5, again, which we've shown to be this point here. So what I want to do now is I want to go ahead and I need to change this -1 into the letter A so that I can figure out what the value is going to be. So we're going to do that. So here I'm going to put in A. instead of writing y, I want y value to be 5. And instead of writing x, I want the x value to be -4. And actually, I want to square that -4. And then I want to make this plus 5.5. And again, I'm seeing a mistake up here. Let's fix that mistake. I actually want to show that the x itself is the value that's being squared. So now everything is matching up properly. So I want to solve for a, so I can figure out what the compression will be to go through this point. All right, so let's go ahead and subtract 5.5 from both sides. All right, doing that subtraction, this here cancels. On the left-hand side here, I'm going to be left with a -0.5. And then I bring down the a. -4 squared is actually 16. And then I'm going to divide both sides by 16 so that I can isolate the a. In doing so, I see that a has a value of -0.5 over 1.6. So that's what we're going to place at the beginning of our parabola to show that it goes through the point -4, 5 and through the point +4, 5. So let's go ahead and do that. So we're going to get rid of this here. And it was -0.5. And I wanted that quantity to be divided by 16. And now notice that we do have our parabola going through those 2 points. All right, next I want to work on the domain. Here I want to limit it. I want to limit it because I see here I have the smallest x value is -4 and the largest x value is a +4. So that's what I want to limit it to. So here we're going to go from -4 less than or equal to x less than or equal to 4, and then that gives us the top part of the crown, or the top part of the helmet, which is the parabola. Now let's work with what I'm going to call here is the absolute value 1, and that's the V shape that's going to be made here. And let's go ahead and show that. So here, let me go ahead and put that in place so you can see it better. And actually, let's scroll up so we can see everything. So I want it to be, this here is going to be the first one that I want. All right, and I've already placed the dots in, so we're going to do that. So the function that we want to write here is y is equal to, again, some value, I'm going to say +1 times the absolute value of x. So that puts us right here. I need this shifted up. I need this shifted up 3 units, so I'm going to actually add 3 to this. So that places it right here. And then notice for this one here, I'm not actually going to have to do the compression, or the constant here is 1, so that's fine. So I don't have to do an equation to figure out how to go through the points -1.5 and I'm sorry, -1.5 comma 4.5 and +1.5 comma 4.5. All I need to do now is actually limit it. So the domain here is going to be from -1.5 to +1.5. So let's put this in place. -1.5 less than or equal to x less than or equal to +1.5. All right, and that gives us that part. And now we want to create what I'm going to call the second absolute value, and that's going to be the line that we see here. And I've already got those points on the other page, so let's show that. So here for these points, let's turn that on. We have the points here, -4, 4. I'm sorry, +4, 4. And then the vertex area of the absolute value is going to be at 0, 2. So again, let's write another absolute value. So y equals, I'm going to again be explicit, 1 times the absolute value of x. And there I have, here I have the absolute value, but I want it to be shifted up so that it's on this point here. Excuse me. So that means I need to add 2 to shift all these points up. So I add 2 to my function here, and then it's not wide enough. So again, I need to figure out what value to change this 1 and 2 so that this, the blue line here goes through the -4, 4 and the +4, 4. So let's go ahead and go back. And we're going to, this time we're going to use the +4, 4 as the values. So our beginning equation is y equals absolute value x plus 2. So let's go back up. And let's see, let's go right here. Let's change the color. Let's go ahead and go to this blue. All right, and we had y is equal to, whoops, I want the blue. We said that y was equal to the absolute value of x plus 2, and the point that we wanted to use was 4, 4. So, and then we have the a value here. So I'm going to place in the y value, 4, which is from this point, is equal to a. The absolute value of x, again, is going to be that 4, and then I want to add 2 to that. Well, I'm going to go ahead and evaluate the absolute value of 4. Well, that's really just 4. So this is really 4a plus 2, and this side is 4. Now I want to solve for a. So I'm going to subtract 2 from both sides. In doing so, this here becomes 2 is equal to 4a. This here goes away. To isolate the a, I divide both sides by 4. So those 4's cancel, and I'm left with 2/4. But 2/4 is the same thing as 1/2. And 1/2 we can write also as 0.5. So that's going to be our compression value. So let's go ahead and add that. So let's get rid of this 1, and let's add in a value of 0.5. All right, and notice that our absolute value does go through those 2 points. And now let's apply the domain. And the domain here is from -4 to this +4. So -4 less than or equal to x, less than or equal to 4. And then we see that we have the what we're looking for. We have the parabola, and then we have the two absolute value functions. And when we look back at what we've done with our analysis, this is what we have. All right, so that sums up this tutorial. Next, we're going to work on the outlines just using linear functions. Thanks for watching, and as always, please subscribe, comment, and keep watching. Thank you.